Welcome to the explainer. Have you ever stopped to think about how a simple click can launch a whole video game? Or how your phone just knows what to do when you tap on the screen? Well, today, we're going to decode that secret conversation. We're going to learn how to speak the language of computers, and our journey starts with one of the most important languages ever created. So let's dive right in. You can't just talk to a computer the way you talk to a friend, right? It doesn't get hints, it doesn't understand context, it needs everything spelled out perfectly. So how in the world do we bridge that gap between our big, creative ideas and the cold, hard logic of a machine? You see, deep down inside, every single computer speaks a very, very simple language. It's a language that doesn't have any words or letters. It only has two characters, a 0 and a 1. That's it. This is called machine language, and it's the only thing the computer's brain, its processor, can actually understand. Now, imagine trying to write a program using only zeros and ones. It would be, well, almost impossible for us humans. It's like trying to have a conversation with someone who speaks a totally different language. We need some kind of translator to get our ideas across. And this slide just shows that difference perfectly. On the one hand, you have how we think, in words and concepts. Add 4 and 5. Simple. We call that a high-level way of thinking. But on the other hand, you see how the machine thinks in this massive, crazy stream of zeros and ones. That's low level. Our whole goal here is to find a way to connect these two very different worlds. So to bridge this huge communication gap, some really brilliant programmers created special translator languages. And one of the most important, one of the most influential of all time is the language known simply as C. Exactly. You can think of C as this perfect middle ground. It's a high-level language because it uses words that look a lot like English, words that we can actually learn and understand. This is awesome because it lets us focus on the logic of our problem. The what do I want to do, instead of getting lost in all the tiny details of the hardware. Okay, but wait a second. If we write our instructions in C, the computer still needs them in its native language of zeros and ones. So how does that happen? Well, this is where a really special program called a compiler comes in to do all the heavy lifting for us. And this quote is just a fantastic way to think about it. A compiler takes our entire C program, what we call source code, and translates the whole thing at once into machine language. It's just like creating subtitles for an entire movie before you even press play. And the best part? Once it's compiled, the computer can run that program again and again without ever needing to translate it again. It's super efficient. So, just like any language you might learn in school, C has its own alphabet, its own vocabulary, and its own grammar rules that we need to learn. These are the absolute basic building blocks we'll use to start writing our instructions for the computer. C actually has 32 of these special words, called keywords. You can think of them as reserved words that have a very specific meaning. For example, you see words like int, which tells the computer we're about to work with a whole number, or if, which helps the computer make a choice. And because these words have special built-in jobs, we can't use them for anything else. They're the core vocabulary of the C language. Okay, so what if you need the computer to remember something, like a player's score in a game, or their name? Well, for that we use something called a variable. And just like the slide says, it's really just a name we give to a spot in the computer's memory. It's like putting a label on a box. We don't have to worry about the complicated memory address, we just use the simple name we gave it. Now, here's a really important rule in C. Before you can put anything into one of these boxes, you have to tell the computer what kind of stuff is going to go in it. This is called a data type. It's basically like putting another label on the box that says only whole numbers allowed, for which we'd use the keyword int, or maybe only decimal numbers here, where we'd use float. You gotta be specific. All right, so we've got our basic words, our keywords and variables. But how do we actually put them together to form sentences and paragraphs that tell the computer what to do? We do that with something called functions. A function is just a named chunk of code that does one specific job. The magic here is that once you've written it, you can call it by its name anytime you need that job done, and you don't have to rewrite all the code. It keeps everything neat and tidy. We've actually already talked about a built-in function called printf. Its only job is to print things on the screen. But what's really cool about C is that it lets us create our own custom functions too. And this all comes together in a basic recipe that you can see right here. First, you include header files. Just think of these as dictionaries that you give to your program so it knows what the built-in functions mean. Second, every single C program has to start in a special function called main. That's the starting line. Third, you write your instructions, called statements, and you'll notice each one ends with a semicolon. That's just like the period at the end of a sentence. And finally, you end with a return statement to say, hey, we're all done here. So you might be thinking, okay, this all sounds a little old school. And you're not wrong. C has been around for a while. But it is still incredibly powerful. And I promise you, it is hiding in all sorts of devices that you use every single day. And this is why it really matters. Learning C gives you this deep, fundamental understanding of how software actually talks to hardware. It's the language that powers our operating systems, our web browsers, even the tiny computer in your microwave, because it's fast, it's efficient, and it gives the programmer a ton of control. That long-lasting power is no accident. A huge moment came back in 1989 when the language was officially standardized. Now, this was a massive deal. It meant that a C program written on one kind of computer could be reliably compiled and run on a totally different one. That kind of stability is a huge reason why C is still a bedrock of the computing world today. So now you know the basic words and the basic grammar of this powerful new language. A whole world of creation has just opened up. You could build anything from a simple calculator to the software that controls a robot. It all starts right here with these fundamentals. So the only question left is, what's the first conversation you want to have with your